So let's get started. So one of the main things I want to connect a little bit is in grade 10, everyone gets very familiar with this thing called SOHCAHTOA. And it works super well when your angles are less than 90. So, if you have sine of 45 or cos of 45, what we would call quadrant 1, things work really well. But when you get something like the sine of 210, this definition when angles can only go up to or less than 90, it kind of needs to be expanded. And so what we do is we switch to this definition where we start using x's, y's, and r's some of the time because it allows us to get to the Cartesian plane. I just want to ask you, what is x the same as if I connect it to grade 10 SOHCAHTOA? So what is x the same as, and what is y the same as if we connect it to grade 10 SOHCAHTOA? Pop it in the chat there and let me know. So x is the same as a or adjacent, and y is the same as opposite, absolutely, and r is the same as h. So it's really just the same definition from grade 10, except it allows us to handle angles bigger than 90. So for example, if I imagine the sine of 210, and I want to think about what that would look like in this definition of trigonometry, this would end up being in quadrant number 3. I'd have to go 180 plus a bit extra, so that would be 30, and I would get to this angle over here. But the triangle that I use to figure out what the sine of 210 is would actually only have an angle of 30 degrees in it. And if I look at this triangle, the y would be here, the x would be here, and the r would be here. So this is why the sine of 210 and the sine of 30 are very connected, because in this definition where we use the cast diagram, so CAST, the 30 is actually the angle that's being used. Can you give me a thumbs up if you understand the connection between the expanded definition of trig with x, y, and r and the sine of 210 and all that? Just want to check if you're following what I'm doing here. So where did we get the 30 degrees from? So if you imagine the sine of 210 can be written as the sine of 180 plus 30. Okay, I can see it's very much a mixed bunch. So I wanted to show you how you would represent the sine of 210 on the Cartesian plane, but still using right-angled triangles. Now, in the last lesson, we spent a lot of time rewriting angles in the form of angles in the different quadrants. So this would be theta, that would be 180 minus, this would be 180 plus, this would be 360 minus theta. Now, what I'm trying to show you is when we take the sine of 210 and we imagine seeing that angle, it's going to go 180, and then it's going to go a little bit further, well, extra 30, and that extra 30 is the angle that is inside the triangle. And so I'm trying to show you how the sine of 210, you can't actually draw a triangle with degrees of 210. You have to draw a triangle that's smaller, but this gives us a story that backs up this idea of a bigger angle. Okay. Now I want to ask you something else. In quadrant 3, is x positive or negative? Is y positive or negative? Is r positive or negative? And I want your answer in the chat. Is x positive in quadrant 3? Is y positive? Is r positive? What's the story there? So r is always positive because it's a radius. Yes, that's correct. X is negative because it's in quadrant 3, yes. What about Y? Y should also be negative. Okay. So what I want to work out now, or what I want to show you is the tan of 210 positive or negative? Is the sine of 210 positive or negative? And if I look at the definition over here, sine is y over r, and sorry, tan, well, I've done it the wrong way around. Sorry, guys. Sine is y over r, and tan is y over x. And so in this quadrant, y is negative and x is negative, and a negative divided by a negative is positive. Whereas for the sine of 210, the y is negative, the r is positive, and so that ends up being negative. So this is also just trying to show you why the tan in this quadrant is positive. The reason it's positive is both x and y are negative, and when you divide them, you get a positive. Whereas y is sine negative in quadrant 3. Well, because y is negative, r is positive, and what's a negative over a positive? It's a negative. So all I was trying to show you now is how the x, y, and r come into trigonometry in grade 11, and to show you that the cast diagram that we learned about in the previous thing does still make sense. Can I have a quick thumbs up if you understand what I was saying there, and a thumbs down if you feel a bit lost from that? Okay. Awesome, awesome, awesome. Now, again, there are some students who are still confused. Don't worry, that's why we've got the lesson today. But let's just have a quick look at this. If you think of quadrant 3 angles will always be 180 plus the theta. And then if we go down to quadrant number 4, I want to ask you, if you look at this 360 minus theta, 360 would go the whole way around. But if you minus theta, you have to go back the other way. And so that's why we end up 360 minus theta ends up being here. And if 360 minus theta gets here, the angle that is inside the triangle will just be theta. It'll just be this bit over here. And that's one of the things that's really going to come up today. Whenever we use the reduction formula, we ask ourselves, how far away is the nearest horizontal? So in the situation like this, 360 minus theta, that's just theta away from the nearest horizontal. I'm Sipo. I'll go back in a moment. I want to actually do some practice questions with you where I make this a little bit less intimidating. So we did this in the previous lesson a little bit, but I just want to check that you still understand them. So if I ask you to reduce number 3, number 4, and number 6, if I do number 3 for you, what we're going to start doing today is when we use the reduction formula, we ask, in what quadrant is this trig expression in? So in the chat, tell me what quadrant we're in. Okay, we're in quadrant 4. So what will that look like? It looks like 360 and then minus theta. So we go back a little bit. So my angle is going to be here. In this quadrant, is cos positive or is it negative? It's going to be positive. So we write positive. Then we ask ourselves, what is the ratio? It's cos. And how far away is it from the nearest horizontal? It's just theta away. So I get plus cos theta. So this reduces to this. The really important thing I look for is how far away is the nearest horizontal and what quadrant am I in? So I want everyone to try and do number 5 and 6 now. What do you get for number 5 and what do you get for number 6? What I'm going to start doing is like a little drawing to help me. So 180 minus theta, what quadrant is it in? It's going to be in this quadrant. And since this is how far away it is from the nearest horizontal, and we get minus tan theta. Now, there is a little bit of in the last lesson, I said we were going to hold off on this one, but I want to come back to it now. How do I visualize 360 plus theta? Can anybody come back and help me to which quadrant is 360 plus theta is going to be in? How would I visualize an angle of 360 plus theta? And maybe you can put your hand up and come online if you feel comfortable explaining your thinking. Anybody feel comfortable explaining what process they go through? I see lots of people are saying quadrant 1. Aha, so Noisy, tan in this case, 180 minus theta puts you in quadrant number 2. Quadrant number 2, not quadrant 3. Okay, so 360 plus theta is actually going to be 360 all the way around, and then I go a little bit further. So my triangle is actually going to be in this quadrant. And the bit that I'm interested in is just going to be theta over here. Because everything is in quadrant 1 is positive, I get plus cos theta. So the thing that I'm doing a bit differently today is in the last lesson, I spent a lot of time rewriting things in terms of the nearest horizontal. So if I said to you like the sine of 330, I would rewrite it by going the sine of 360 minus 30. And there's nothing wrong with that. But what I'm really interested in is how far away is 330 from the nearest horizontal? And it's 30 degrees away. And so you can actually do this quicker by saying, look, for sine of 330, in which quadrant is that in? That's going to be in this quadrant. In that quadrant, sine is negative, and then you just write minus sine 30. So I just want to clarify that because I'm going to start moving a bit quicker, but it's basically two things. The angle tells us what quadrant we're in. Then to use horizontal reduction formula, we say it's either positive or negative. And then we say, how far is it from the nearest horizontal? So let's do a question like this. Let's do a question like these ones here. I want to know, what would you reduce these 3 things to? I want you to rewrite these. I'll call them A, B, and C. And the first thing for the first one, I ask myself, what quadrant am I in? I'm in quadrant number 4. In this quadrant, sine is negative. So I write minus sign. And I ask myself, how far am I from 360? I'm theta away. Remember that the horizontals are 0, 180, 360, or minus 180 and minus 360. So I'm always asking how far away am I? So I hope that helped a little bit. Keep those answers coming. And maybe someone can come on and tell me how they did it. Sinosipo, I can. So for number B, or letter B, I still am in quadrant 4. So 360 minus theta means I end up in that quadrant. And in this quadrant, cos is positive because of the cast diagram. So plus cos. And how far away is 360 minus theta from 360? It's just theta away. So it becomes that. And then the last one is going to be minus tan theta. And these are what we call reduction formula. But all we're asking is, what quadrant is it in? How far is it from the nearest horizontal? That's it. Let's try and do D, E, and F. And if you have a question, I really encourage you to come online now and ask your question. I'd love to engage with it. Let's just see how D, E, and F go. This is a negative angle. A negative angle goes in the opposite direction. So positive angles go this way. Negative angles go this way. And if somebody feels like sharing for D, what quadrant am I in for D? So what quadrant should I be in for D? Nomfundo has given us a good guess. For minus theta, the angle goes in this direction, which means that I am in quadrant number 4. Yeah, it's in the 4th quadrant. So I know this is plus. No, I lie, it's not plus. I'm absolutely fibbing. In this quadrant, it's negative. And then I say, how far away is minus theta from the nearest horizontal? It's just theta. So I get minus sine theta. Yeah. Okay, Rafense, what you're thinking about is you're thinking about what's called a co-ratio reduction formula, which I'm going to show you very shortly, okay? But I just want to get this 100% in your head before I start messing with it.
Mr. Ace?
Yeah.
We have a hand up.
Cool. Let's unmute. Sorry, I couldn't see my screen. Quirin, let's go to
Quirin.
Yeah.
Hello, sir.
Hey, how's it going?
I'm good, and you?
Very good. What can I help you with, or do you have a question, or yeah?
So I just want to explain how I always remember which is positive in the quadrant. So I go by this saying it's all strippers take cash.
Okay. Whatever works for you, whatever is memorable enough.
Yes,
absolutely. Yeah. Let's have a look. Takes cash. All stations to Cape Town, or a couple of different things like that. Yeah.
Yes, sir.
Cool. Thanks.
Yeah, thank you.
So what we have in this one is with cos, we have quadrant 4. Sorry, I lie. I'm going the wrong way now. There. And so it will be positive cos theta. And then for F, it's going to be minus tan theta. Okay. See if you can do these 3 here. So D, E, F, A, B, C, D, E, F, G, H, I. Can you do G, H, and I using the same idea? There's some good ones. Yeah. Look, guys, whatever gets you to remember this is all good. Yeah.
Mr. Ace,
Yes.
can you please explain for Luyolo which trig ratios are positive and negative in which quadrants?
Okay, so this is what everyone is saying about this cast diagram. So all the trig ratios are positive in quadrant 1. Only sine is positive in quadrant 2. The other ones are all negative here. In quadrant 3, tan is positive, everything else is negative. And in quadrant 4, cos is positive and everything is negative. So since this is going 360 plus theta, this is actually going to be in quadrant 1 for all of them, because 360 goes here, and then you add theta to get here. So everything is going to be positive in this quadrant. Now, since one of the horizontals is 360, 360 plus theta is just going to be theta away. And so these answers are going to just be like that. Yeah. But that was actually not too bad. Let us do one more question before the break. And if you need to take a screenshot of these, but basically we've done a couple of different types of reduction formula now. But I want to show you a question before I go to, let's do some from here. So I want you to evaluate the following one like this one, and let's also do this. Now you have to use the reduction formula, but you get one extra thing. You can use special angles or special triangles. So I will give you those special triangles from my memory. So 1, 1, root 2. And I want to see, can you reduce, let's start with 6. And can you reduce 6 and get a reduced thing and then put a value in for it? So see what you can do. Let's start with 6. And then if there's time, we'll do 9 and 10. Otherwise, we'll come back after the break. Don't worry, Rafense. What I would do when you see the square is just ask yourself, it just means this. So tan 225 times tan 225. You still have to reduce those 225s, but you can do that. Ask yourself, what quadrant is 225 in? So if you do get stuck, you can always rewrite tan 225. It's in quadrant 3, so it should be 180 plus 45. So this is where the last lesson was quite helpful in showing you how to break it down. So 180, and then plus 45 gets me to 225. Now, I like the fact that I'm in quadrant 3 because I'm dealing with tan, which means this is plus tan 45. And this one over here is plus tan 45. So all I need is a value for tan of 45, and that should give me my answer. So can anybody use the special triangle to evaluate tan 45 times tan 45 without a calculator? So this is O, that's A, that's H. But in tan, it's just going to be 1 over 1 times 1 over 1, which is 1. Yeah. I want you to do number 9 and number 10. Let's do those two. So the answer for 6 should be 1. You guys are doing really well. Well done, everyone.
They are. I think they started panicking a bit when they got 1 as an answer.
Yeah. I always have to do a little bit of theory, but then once we come back to the practical implementation, it's like, it starts to become a lot more, yeah, I suppose it's easier to understand a little bit.
I know the feeling though. Sometimes if you get 0 as an answer, you're like, oh no, I'm wrong. I'm definitely wrong.
Or 1, or -1, or 2.
Yes.
You're like,
Sometimes the answer is simple.
no. So for tan 405, you could write it, you could break it down if you like, or you can visualize it to go 360 plus what gets me to 405. And it feels like it should be 45. So that's plus tan 45. What does that give me for number 9 as my answer? So plus tan 45, I need to evaluate that. So it's going to be 1 over 1. 45, yeah, because it's O over A, so it's 1 again. Now, what about number 10? Number 10 is a bit harder. Keep those answers coming. So 1020, oh, that's an enormous number. So I go 360, 720. Okay, so now I might need to start jumping with my calculator. So let's have a think. So 720 plus 90 plus 90. So that gives me to 900 plus another 90. So 990. So I end up in quadrants. Let's have a look. So 720 is here. Then I get 90, 90, 90, and I'm at 990. And then I've got 30 more to go. So basically, I'm 60 degrees away from the nearest horizontal, which would be 1080, and I'm in quadrant 4. So what is this going to reduce to? Plus cos 60. And then using this triangle, I should get, if that's A and that is H, I should get 1 over 2 as my answer. So the cos of 1020 will reduce to plus cos 60, which can then be evaluated to a half using my special triangle. Okay. Now, if you got, think about this. What are 3 complete rotations? So it's 360 times 3 would be 1080. So that would be going all the way around 3 times. I don't go to 1080. I'm 60 degrees short. And so that's why I'm using 60 for the reduction formula. Okay. Cool. I think it is time that we have a break. But before we have that break, I just want to have a quick vote in terms of how much you guys are feeling comfortable. So thumbs up if you're broadly feeling comfortable. Thumbs down if you're feeling a bit unsure here. Okay, a bit of a mixture, but that's fine. Don't worry, after the break, we will keep going. And it's just a process that we will keep working at. Okay, everyone, I want you to stand up and we are going to take a brain break. So I want you to stand up from your desk and I want you to join me in moving your body around. So swing those arms out. You've done a solid 35 minutes. Your brain is like, please give me a break. I've been working hard. So swing those arms out. Okay. And then let's do some small circles. Some small circles, and then some bigger circles. And then the biggest circles. Okay. Then let's stretch our arms like this. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, roll the shoulders. Hold them back. And roll them forward. And then it's time for some high tempo cardio. I know I did say we would do mountain climbers today, but I'm using my teacher power to veto because I still don't think it's safe. But we're going to do jumping jacks and we're going to do 10 to start with. So 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 more. 1, 2, 3, 4, 5. Well done. Well done. And have your glass of water nearby and indulge yourself as you take a breather.
David, you promised push-ups today.
Did I promise push-ups? Oh, I'm getting old, guys. You got to start for that. Your memory goes.
I remember burpees, not push-ups.
Oh, is it? Yeah. Done too many sessions. Okay, here's your question for the day. You go to the doctor because you're ill, and he prescribes 3 pills and tells you to take them every half hour. How long do the pills last you?
Dun, dun, dun.
Yeah.
Burpees do take a bit of effort, though. Hey.
Yeah.
Shoot.
I do. I used to do CrossFit before school. At one of my old schools, it was like an extramural in the morning. And that was really good, but it is flippin' tiring.
Yes.
Okay, so here is the answer. You go to the doctor and he prescribes, and you take 1 pill, and then you wait 30 minutes and you take another pill, and you wait 30 minutes and you take another pill. So how long do the pills last you? They last you 60 minutes or 1 hour. Okay, so I know. I told you, I'm always sneaky with these. Here's the reason. When you first get it, you take a pill, okay? And then once you get home, because obviously you're with the doctor, you're going to take it there. Then you get home, you take another one, and then you take another one, and then it's run out.
Sorry, we tricked you guys.
Yeah, you disagree, Okonele. Well, here's the other thing. Even if you wait till you get home, right? So even if you don't take it in the doctor's office, you take 1. Now, how long does it last you? Well, it lasts you 30 minutes till the second one, and then another 30 minutes until the last one. So it's an hour to take 3 pills. Okay. I'm glad you understand. Fantastic. I do my best to find something interesting. Okay, we're not quite mastered this yet. So let's do, like, say, another one. So let me make up something like for you guys that you could just to practice this one. So if I say to you, what is the tan of 780? And what is the cos of, let's go with minus 580. I want you to evaluate those two angles, and I'll leave the special triangle up here for you. And what I want to suggest you do is, you can see that these are big angles. So the idea is that they're going to be multiples of 360 in there. So ask yourself, if I did 1 360, yes. So you could write it like that. Yes, lovely. Absolutely. I didn't actually do that in this one, but you can write it as the cos of 1080 minus 60. And that is what it would be if you went round and round. 1080 would also be a horizontal. Yes. That's what I'm trying to get at when I say it's 60 degrees away. So this would be plus cos 60 for that one. So the cos of 780, now you could write this as tan 720 plus 60, or you could see and go 360, 720, and then another 60 degrees. So it feels like this should be plus tan 60. And what's that going to be? So plus tan 60, if I go to this, it's going to be root 3, which would be the O, and the A would be 1. So root 3 over 1, whatever that is. Now, I've got negative angles on the next one. So minus 580. Now, all a negative angle means is I'm going the opposite direction. So if I'm wanting to do this, I go minus 90, minus 180, minus 270, minus 360, minus 450, minus, where was I? 540. This is actually not going to have a simplification here because, is that right? 540. I get this being in quadrant, or it is going to have a simplification, but just check. Do you all see that this is in quadrant 2? So you are going to get minus cos something. So I'll re-explain this because I can see I've lost some of you here. If I go in this direction, I get minus 90, minus 180, minus 270, minus 360. Now that isn't enough to get for my minus 580. So then if I go another 90, I get minus 450. Then I get minus 540. And then if I go a little bit further, I get to minus 580. So this bit over here is going to be 40. Now in this quadrant, cos is negative, so this is going to be minus cos 40. Another way of doing this is to say that this is minus 540 minus 40, which is just going to be the cos minus the cos of, yeah, sorry, it's going to be minus cos of minus 40, and then go from there. So it can't be minus 360 from 5. So what I'm going to suggest, I don't want to go too, because it can get a little bit like, I want to show you kind of the easiest and way to do it. There are many ways of getting it, but we should get the same answer. So can everybody see that I end up in quadrant 2? So give me a thumbs up if you see I get to quadrant 2. Give me a thumbs down if you have no idea how I get to quadrant 2, because that's important. Okay, so there are many ways to do this, but the easiest way to do it is to think, how far away is it from minus 540? So I'll do this once again just to show you. Okay, so let's do it together. Now, you're not often going to get minus 580, but it does happen sometimes. So if I go in this direction, minus 90, minus 180, minus 270, minus 360. So I'm at minus 360. Now I go minus 450. Now I'm at minus 540. So ask yourself, how far away is minus 540 from getting to minus 580? Don't I have to just go another 40 degrees in that direction? That quadrant, this is the first, that's the second, that's the third, that's the fourth. So all that's going to happen now is I know that it's negative and it's 40 degrees away, so it's cos 40. Now, I can't use special triangles for this one. Why can't I use special triangles? Because 40 is not a special triangle. So I just made that up in my head. And so 40 is not a special triangle. Okay. I can see negative angles cause a little bit of distress. So let me give you another question like this. So we'll say, what is the cos of, let's see if I can do this in my head. The cos of minus 405. Can you reduce, what is the cos of minus 405? And this one you might be able to evaluate. Give this one a go. If I've done it properly in my head, I think you will be able to use special triangles. Okay. So, Kat, you were asking about formulas for negative angles. So while people work on this, you can actually generate lots of formulas. So if you're in this quadrant, it'll be minus theta. Over here, it would be minus 180 plus theta. Over here, it would be minus 180 minus theta. And then over here, it would be minus 360 there, plus theta. But I find that students, when you get too complicated with formulas for negative angles, it becomes a little bit hard to understand what's going on. So my approach to this is to think, okay, what quadrant is minus 405 in? So I go, okay, well, it's negative. So it goes minus 90, minus 180, minus 270, minus 360. And if I keep going a little bit more, I get into quadrant 4. So how big is this angle here? It's 45. So in this quadrant, cos is positive. And so this gives me plus cos 45. Now, if I want to know what plus cos 45 is, it's just going to be a over h, or 1 over root 2. Or if you've rationalized the denominator, it will be root 2 over 2. Can we have another vote? Thumbs up if we're feeling happier with negative angles. Thumbs down if you're still not feeling happy. I just want to get a feel for the mood in the room. Okay, let's do one more. Well, let's do 2 more. So if I say to you, what is the cos of minus 180 plus theta? That's one negative angle question I want to ask you. And then what about if I said to you, what is the tan of say minus 360 minus 480? See if you can simplify those two. Okay, so Obile, your question, don't negative angles move in the, so negative angles move in the clockwise direction. So that's the direction a negative angle goes in, it's the clockwise. Normal angles, positive angles, go in the anti-clockwise direction. All right, so let's see what we get for this one. So minus 180 would go there, plus theta goes this direction. So it feels to me we're in quadrant 3. And it's theta away from the horizontal, so I'm minus cos theta. You don't have to rationalize, Alyssa, no, because we're using this special triangle, so you don't. What about minus 480? Now, if I'm going negative, I go this direction, and then I go, so that gets me to minus 360. Then I get to minus 450. Then I get to here, I get to minus 480. Now, the problem is, this is actually going to be careful. So 450, this is going to be 30, but I don't want to know, I want to know where the nearest horizontal is. So watch out for this. So if you imagine you went the whole way around, you got to minus 360, and this is minus 450. When you use the reduction formula, you don't want to know where the nearest vertical is. So this is the line that you get to, but the triangle that I'm making is not with the vertical, it's with the horizontal. And so the nearest vertical will be minus 540. And so it's going to end up being positive tan 60. And if we use positive tan 60, what do we get for that? So positive tan 60, that would be this. So it would be root 3 over 1. Yeah, exactly. Now, what I want to kind of rewind or zoom out for a second is today we have learned how to really apply the reduction formula using the horizontal axis. It's been pretty much the whole focus of the lesson. Now, 80% of the time, you will use the horizontal axis. And what I would suggest, all you need to do whenever you're reducing trig expressions off the horizontal, you ask yourself, what quadrant am I in? Is it positive or is it negative? And then ask yourself, how far away am I from the nearest horizontal, wherever that nearest horizontal will be, if it's minus 540, minus 360, whatever it is. So the reason I had to use 60 and not 30 is if you imagine when I went around, I got to minus 360, then I got to minus 450, then I went 50 degrees further and I got to this red line and I went 30 in. But the question is, how close am I to the nearest horizontal? I'm not 30 from the nearest horizontal. I'm 60 away because of this. I'm looking at this, not the 30, which is over here. Okay, so Tova, I hope that helps a little bit. You can practice some more questions doing this. Now, just before we finish for today, I didn't cover something called co-ratios, or like how do you convert from sine to cos? I will do a little bit of that in the next lesson. I'm going to move lessons around a little bit, but if you want to reduce something from a use a co-ratio, when we talk about co-ratios use the vertical axis, okay? Whereas the reduction formula or the normal reduction formula uses the horizontal. So I just want to close today with just giving you a simple example. So if we look at a triangle like this, and it was 60 degrees, I want to know how far away, and if I say to you, I'm going to get the sine of 60, whatever that is, I want to know how big is the red dot? Okay, so the red dot is going to be 30. So we would say that this angle is 30 degrees away from the nearest vertical. Now notice how it is a different word that I'm using. Now, if you use the vertical axis, you still do the same thing. So you ask yourself to start with, is sine positive or negative in this quadrant? Well, it's in quadrant 1, so it's positive. Now you ask yourself, how far away is it from the nearest vertical? But because it's from the nearest vertical, you don't write sine, you write the co-ratio of sine, which is cos, and then you write the cos of 30. So when you use the vertical axis, what you have to do is you change the ratio from sine to cos, or you change it from cos to sine. And in the next lesson, I will begin a little bit with that. But just to show you another example of how this could work, if I say to you, the sine of 240, if I wanted to visualize the sine of 240 and I wanted to use co-ratios, 240 would be in this quadrant, and it would go all the way to here, and this would be 60 degrees. I want to know, what is the red dot this time? What is the red dot this time? So in this case, if I'm looking at the vertical, it's going to be 30 degrees away. Okay, so how would we reduce the sine of 240 using co-ratios? Well, we ask ourselves, is the sine of 240 positive or negative? Because it's in quadrant 3, it's negative. Because I'm using co-ratios and I'm using the vertical, I write down the co-ratio of sine, which is cos, and I write that. And this would be minus cos 30. Now, I will do more of this in the next lesson, but there is a one quiz question on this. And I spent a bit more time doing negative angles today, but I think it was worth it to really give you a good understanding. Okay. Lebo, if you could put the link to the quiz in the chat. Everyone, we've done a lot of work today, so I really recommend some of you maybe re-watching this video just to get a thing of what I did. But really all I did for 50 minutes, I spoke about different angles and how I can reduce them off the horizontal. And then the last 5 minutes, I started talking about reducing off the vertical using co-ratios. And yeah, we'll carry on with that in the next lesson. But I hope that that was helpful to you. And I think make sure you've got the link so you can do the quiz before tomorrow. And yeah, let me know in the chat how you're feeling. Did you find the lesson helpful? Was it confusing? I'm curious to know, because today I did talk a lot, but it felt like I was trying to respond to what I saw in the chat. Okay. Fantastic. Yeah. And don't be afraid, if you want me to answer a question in the next lesson, you can just pop it in the chat now, and then I can make sure I'm ready for the next lesson. Rafense, your quiz, we mark the quizzes on Thursday afternoon. That's why I want you to do it before Thursday, yeah. Or before the end of tomorrow. That's why. Okay.